Entity Framework Core has a fundamental requirement that everything you put into it must be mutable, or otherwise it won't be able to track changes in objects. That's reasonable. Yet, there is a growing question today. Can Entity Framework Core track immutable records? The answer is no, not natively. However, if you configure EF Core in a very specific way, which I will show to you in this video, then it will suddenly start tracking changes in immutable records. The story is much larger than what can fit in just one video, but we must start somewhere, so let's start there. There's one immutable record type, there is one Entity Framework Core 10. Let's have fun. I have prepared a demo here. This is the almost empty program.cs. It just drops the database, recreates it, and applies migrations. The DB context is currently empty. I plan to add one model to it. So it will be the models namespace. I want EF Core to start tracking invoices. So the invoice type it will be. But observe, this is the record type, immutable record type. The rest will be business as usual when it comes to modeling. I will run over this really fast. There is nothing new except that this type is a record. There will be the customer name, there will be the invoicing date, a private ID, which is an implementation detail of the relational table. I will spice things up by adding an enum to the record. I will spice them up even more by adding a record struct invoice number with 2 integers in it. Still, if this were just a class, we would have absolutely no reasons to worry when configuring the DB context here. I will add the DB set of invoices. Then comes the entity configuration, the conversion for invoice number, maximum length, unique index on invoice numbers, complex but straightforward. There is nothing that specifically relates to records here. When I add migration, it will look exactly the same as for a mutable class. So far, EF Core didn't even notice I gave it a record, because the record has everything the class has: constructors, properties, fields, everything. And that's all it needs to configure it. But now I want to start using this record. I will do that in a series of use cases. The first one will test the creation of several instances which I want to add to the DB context. So in the loop, I will create an immutable instance, add it to the DB context, and save changes afterwards. What do you think? Will EF Core work well with this? I would tell you it will, for a very simple reason. There are no changes to track. The entity added, every entity I added here, will be in the added state. There is nothing to compare it to. And so this will just work. I will prove that with another use case, querying. You can query immutable records the same way you do with mutable entities. Start from the DB set, do whatever you want, like order by the invoice date, collect into the list. This should work. Print all of them out. This is another use case that will work out of the box, because still there is nothing that would confuse EF Core. I will prove that by running one and the other use case. I'm running the application, and here you can see the output. The first block of text is written from in-memory objects. That is what I made in memory. But the second block are the data loaded from the database. You see, the data are the same. Materializing immutable records simply works in EF Core. Plus, inserting immutable records simply worked. So, does it mean everything will work? Let's see. Don't rush. Deleting I want to isolate the invoices that are in the state editing, not issued yet, in year 2025, and with even sequence number. Let me remind you that after this query executes and after I collect the objects, all those objects will be tracked in the DB context. So, I can loop through them and tell the DB set to remove each of the target instances. After the loop terminates, I also want to save changes. Just to show you that this works, I will query all the invoices from the database afterwards and print them out. And I will tell you, this will work too. Why? Because, again, there are no changes to track. There is the initial object, which I'm then removing. Nothing has changed in the objects. So now we know that inserting or adding to DBset works, querying works, and removing works out of the box. I can prove that easily by running this use case. Here it's executing, and you can see invoices number 2 and 4 from year 2025 are missing, just as I wanted. So far everything works. What has remained? The operation from hell has remained, updating. That is the most complicated operation that exists when working with databases. And that is where EF Core will fall short when it sees records. Here I have isolated all the invoices in the editing state, and I want to update some of them. But my invoices are immutable. I cannot change them. All I can do is to start from an immutable instance and create a new instance which is the updated version of that entity. That is common in immutable design, so that's what I'm doing. If the year number is 2025, I will turn that invoice to the issued state. Otherwise, if its sequence number is odd, I will append an asterisk to the customer's name. All other invoices should remain unchanged. Now, one important note before I show you the problem. There is an ID field in the record, if you remember. With expressions, we'll preserve the ID field and transfer it into the new updated instance. If you don't plan to use with expressions, but if you use constructors, you will lose the ID and your operation will not work. That is how immutable design works. It's nothing related to records or to EF Core. So if you don't want to fall into that trap, then make ID a public property and maintain it yourself. Now comes the real problem. When I save changes, nothing will happen. Because in the change tracker, all it can see are the original instances. It doesn't see anything changed. If I queried the database and printed the invoices out, those would be the old invoices. Nothing would change in the database. So the problem happens before calling save changes. Save changes is not guilty of anything here. We need to do something here. Could I call update for modified instances, hoping that EF Core or DB context or change tracker will get that object and diff it with the original instance? Unfortunately not. This method is reserved for detached entities, and these entities are not detached, obviously. Not only that this won't work, it would throw an exception. The solution I will propose is to repeat what EF Core Change Tracker does already. Identify the entry managed by the Change Tracker associated with the original unchanged instance, then access the current values in that instance and set them to the updated invoice. This call will take all scalar properties from the updated invoice and copy them into the modified instance. There are a lot of problems with this simple idea alone. It's not that simple at all. I have extracted the full logic into an extension method, and I will give you a glimpse into that extension. But before that, let me mention that this video and all other videos on my channel are free thanks to the patrons. By becoming a sponsor, you will have access to the source code of this video and all other videos. So if you like what you are learning here, then please join the growing community of patrons on my Patreon page. You will find the link in the description. Thank you very much. Now let me show you the code, which is actually not correct, but it is just a starting point to give you an idea of the direction in which you should go if you want to work with immutable entities and EF Core. I have pulled this code into the extension so it again looks for the entry and sets the values, but then comes the continuation, because set values on the current values only sets scalar values. It ignores navigation properties. So what I also need to do is to walk through all the navigations and recursively update changes in them, separately for navigation collections and separately for navigation references. Only after that, EF Core will understand all the changes that happened to an immutable object. Unfortunately, I told you this implementation is not correct. The call to set the values will actually overwrite the content of the original object, which was supposed to be immutable. That's not good. The true solution is to fall back to detached entities again, but this time in form of a reusable library. If you want to see how this library works, there is the link to it, to a GitHub repo where I have uploaded it. Please find the link in the description and read this extension carefully, and you will see what you need to do to make EF Core work with immutable records. And it really does. I will add this updating entities use case, run the application again, and you will see that the records have really been updated in the database. This complex updating scheme works on immutable records. The solution is still possible. It's in the GitHub repo, and more videos on that topic are coming. Please read in the description for more details. That includes a very unpleasant question of what happens when an immutable record has a collection of other immutable records in it, and you need to track all that as one entity. But it will all work in the end, don't worry.